PMA 121, you really have to have an Intel processor. So if you have only a Mac M1, you should use a cloud machine like Azure or Google Cloud. Here I'm using one of the classroom machines, which has an Intel processor. All right. And so here, I should already have PuTTY in this machine. This is one of the machines I downloaded. I think it's the Windows 10 version. Why is this not opening? Oh, here it is. Okay. All right, let's see. If I go to downloads, nothing there. How about documents? Well, yeah.
So I'm on PMA 301.
Yeah.
Is that for today's class, or is that just for fun?
Is that what for today's
For
class?
today's class, is that an assignment?
It'll be due. It's not due for a few weeks, though, if it's the Jasmine one.
Okay.
I just mentioned it today because I thought it might help the people that seem confused about assembly code.
Okay.
Yeah.
In the syllabus, today is PMA 221 and 105.
Right.
Are we going to get to those?
Wait, let me see what's going on. 126. Yeah, those are the ones that are due today. I demonstrated 221 last time.
Okay.
And I didn't think 105 needed a demonstration. That's why I didn't bother with it. But yeah, that's all, because it's pretty easy. Yeah, I wanted to demonstrate.
You are demoing, now I'm seeing 201 and 213.
Yeah.
I wasn't sure if people were asking about other classes or.
Oh, no, not yet. These are all stuff from this class. It's a little bit scrambled. This is 121 I think I'm doing. What am I doing?
Yeah, you were on 121.
I think I'm on 21. All right, now I got to do this to get back to that window. Good. All right. Thanks for asking. I don't want to be any more confusing than I have to be. But this one I thought was pretty good. All right, I'm going to have to download PuTTY. I should have it, but somehow I don't. Doesn't matter. All right, there's this file. All right. So now that I've got it, let's see if I can run it. Windows may not let me run it. Sometimes it blocks it. You have to unblock it. Yep, here's Windows protecting my PC. A student showed me the cure for this. More info, run anyway. That's cool. All right, so this is what PuTTY does. PuTTY is just an SSH client. So you can put in the name of a server, like ad.samsclass.info, and you can connect. And when you do, it will ask you to log in with login as. That's all I want to see. That's all it does. And we're not going to bother logging in. I don't have a name and password for that server. I'm just showing you what it does. Now we're going to check the hash. This machine should have hash calc on it already. Yep, it does, although we could use PowerShell also. And I just want to make sure you have the exact version of PuTTY that we're using for this project to work right. So there's the hash, and the down here, I can see the MD5 should start BA7, and garbage keeps popping up on my screen. And it doesn't. Oh, it does start BA7. Okay, so it's the right file. That's what I wanted to see. All right, now that that's done, we've launched it, we saw it go, we see what it does. Now we're going to compress it with UDX. So this is the command that will compress it. I need a command line. Oops, and I keep hitting the wrong button. All right, I need a command line. And I need, all right, somehow I don't have a command line here. CMD, there it is. All right. And let's pin that down here. Oh, I could have used PowerShell, that's why. I would like to pin it, there we go. All right, now, let me make the font bigger. All right. Now, let's go to, I think it's probably in the downloads folder. There it is, PuTTY. All right. Now I'm going to execute the stuff in my clipboard. Not working. Let's try. This is the problem at Microsoft. Copy and paste doesn't really work very well because they are very cruel. And right-click. There we are. So this UPX will compress is the default action to compress PuTTY into puttycomp.exe. But UPX is not found, so let's go to C tools UPX. I think that's where it is. It is. All right, so for some reason, the path is not right on this machine. I just have to add that here. C tools, UPX. All right. All right, now it's compressing. So it took this thing that was 531 kilobytes and shrunk it down to 267 kilobytes. So if I do a directory, you'll see both versions, PuTTY and PuTTY compressed. And we can now compare these two to understand what the UPX packer is doing. All right. So if I launch PuTTY comp, you'll see that it works, which is pretty surprising. It's compressed, but you can run it. If I go to my downloads folder, there's PuTTY comp. If you double click it, it just pops right up. It works. So even though it's compressed on the disk, it decompresses into memory to run exactly the same as the original PuTTY. That's the idea. This is a particular compressor just for running executable code. So now I should be able to run PE Studio. Good. All right. Well, I'm clicking it, but having no effect. How about open? All right. There's PE Studio. All right. And I want to open PuTTY, which is in my downloads folder, PuTTY. All right. And it'll take a little while to populate. So you'll see right, I want to launch a second instance of PE Studio and open PuTTY comp to compare it. So let's go here, PE Studio, all right, and open again. Ah, good. And now I open the compressed one, and we can compare them. All right. So the hashes are different. Indicators show number of suspicious features. Virus total shows false positives. Not very exciting. But now we can compare the sections. All right. So this is the compressed one. And the sections are here. There. So here's the sections UPX0, UPX1, and .resource, which, by the way, is a bug in UPX. When he wrote it, it forgot to compress the resource section, intended to compress it. Here's PE Studio on the normal PuTTY, and here are the normal sections you expect to see, .text, .rdata, .data, and .resource. Notice, by the way, the entropy. Entropy is a measure of how random the data is. If data, and so text is assembly language instructions. It's quite random. The maximum possible entropy is 8 bits per byte. This is 6.6. The R data is similar. The data is much less, 2, so it's not random at all. It's probably readable text, which is not very random, and the same with the resource section. However, if you look at the compressed file, it has a UPX0, which has no entropy because its size is 0. Has UPX1, which has a very high entropy, 7.9. It's almost completely maximum entropy because this is compressed data. Compressed files, you squeeze the air out of them, the entropy goes up towards 8. And here's the resource section with 4. So this is what includes all the data, which is going to have to be decompressed and loaded into memory. All right. And, all right. So the sections in PuTTY compressed, we looked at the entropy and so on. All right, we can look at the imports, and the import list is much smaller, but that's not terribly exciting. All right, and so there's a malware sample here to examine to find a flag, and then the interesting thing is to unpack it with OllyDebug. And this is why you have to have an Intel processor. You cannot run OllyDebug on an ARM processor. So we're going to use, I'm going to close PE Studio, both of them, and I'm going to run Olly, which is a very nice, friendly debugger. The problem is it only debugs 32-bit code, so it's getting out of date. But it's been a hacker's friend for decades. All right, here comes Ollie. And I don't care what you do about your dills. Okay. Let me shrink it down a bit. All right. We want to examine PuTTY and PuTTY comp with Ollie debug. All right. So here's Ollie. Okay. I'm going to make this smaller. There we go. And have, go to my downloads folder and open PuTTY. All right. I'd like to make it bigger. Doesn't look like I'm having any luck doing that. There we go. I can do that. I can do this. There we are. Now, I'd like to make the font bigger. Let me see if I can figure that out. Options, appearance, fonts, there we go. Change. Actually, I think all you have to do is choose OEM fixed font, and that will look better. Now I think I have to right-click, appearance, fonts, all, OEM fixed. All right, that makes it better. And I need another instance of PuTTY, of Ollie, I mean. All right. And I need to get past complaining about things. All right. And now open PuTTY compressed. Now it's warned me, quick statistical test reports that its code section is compressed or something, which is weird. Do you want to continue analysis? I'm going to say no, I think. There, now it loads. All right, now I just want to make this font a little more readable. Font all, and what is this garbage? OneDrive, Microsoft always has to irritate me with advertising their garbage. OEM fixed, all right. All right. So there's compressed. Now notice, this is the real PuTTY. It starts with push 60, then push PuTTY, call PuTTY, move EDI. These are the assembly language instructions that are going to be PuTTY. And this stuff, PuTTY compressed, is very different. Push AD, move, load effective address, it's very different instructions. Now, you can actually read, however, the compressor here. And let me go back to my instructions and see if I want to mention anything else before we get there. There, all right. So, yeah, we showed that the two start with different commands. All right, we're going to view the memory map, and you'll see how it looks. Here is the, this is the compressed one. Let's start with the regular one, which is here. Okay, this is the regular one. If I view memory, it will show you the memory map. And let me see if I can make the font more visible. Font. All right, that's somewhat better. Here's the map of memory, and here's the PuTTY sections. The PuTTY starts at 400,000. All Windows programs think they're at 400,000. That's where they like to load. And so you have PuTTY starting here. Then you have the text, RData, data, and resource lined up here, each being a few thousand big. And here's the code, imports, data, and resources. Now, if you look at the compressed version of PuTTY, which is here, and view the memory, and change the font. All right, now this also loads at 400,000, but see it has UPX0, UPX1, and .resource instead of the other stuff. So it's ready to run a program, but the program it's going to run is not PuTTY. All right, now, if I dump the text section from the normal PuTTY, which is here, I can point to the text section and I can dump the contents. And here's what you see. Here's the same assembly language instructions we saw before, push ESI and all that. Now, if I dump the UPX0 line over here in the PuTTY compressed, Okay, if I dump this, it's all zeros, which is pretty strange. If I dump the next section, which is UPX1, the only other section, it tries to interpret it as assembly language, but it's garbage, meaningless junk, uninterpretable stuff. This is really not assembly language. It's just compressed data. All right. All right, now I want to show you the fun part, which is manually decompressing it. Yep. So we're going to view the unpacking stub, this is so simple, you can see it right here in the debugger. So if I go back to here to see the code, if you just scroll down here, here's the instructions being executed by putty compressed. And if you just go down and down and down a bit, you only have to go through a few screens of code before you hit the end. There. Pretty soon, I'll hit a pile of, there we are. They're all zeros from this point on. So what happens is that is the unpacking stub. All that code, just a few screens of assembly code, is what does the unpacking, and when it's done, it does a jump into putty. So everything up to this point is the unpacker, and I can put a breakpoint here. If I right-click and do breakpoint toggle, it'll turn red and indicate. So now I'm going to run to that point and stop. That will do the unpacking, preparing it in memory, and then stop. So I do that, and now I run it. Okay, so now I run it here, debug run, and it runs, and it stops at the breakpoint. Now, I want to make one more step, and I can do that with the F7 key, or I can do debug step into, the same thing. Because I've done unpacking it, now I want to jump to the start of the unpacked stuff. So it's view, or debug, step into, and now notice what I've got. I've got push 60, push puttycom, move EDI. If I compare that to the real putty, which is here, now it matches. There. The real putty is push 60, push putty, move, call. Now it's fine. So that 2 or 3 screens of code is all it took to do the unpacking. And now in memory, I have the exact putty in the right location too. So that's what the purpose of this thing is. And one thing that you can, if we ran the unpacking code, all right, now you can actually build an executable from memory. There's a thing called ollie dump that will manually dump the unpacked code. So you do plugins, ollie dump debugged process. So it's plugins. And looks like I don't have ollie dump installed here. I'll just talk about this rather than hunting for it. So there's instructions up there how to install the ollie dump. You can dump the debugged process. The only dirty trick is you have to be very careful about the start address. Remember here, it always wants to start at 4550F0. And Windows programs all think they're starting at 400,000. So that shows up here. The start address is 400,000 and the offset is 55050. The sum of these two has to point to the real starting point. And then you can dump it. Now I find that processes dumped in this fashion will not actually run. It's pretty good, but you can still see a lot of things like code in PE Studio and stuff. You can open it in PE Studio and see strings and functions and code pretty well. So you get a pretty good version of the program, but not one that's good enough to run, in my experience. Anyway, that's what I wanted to show you, and there are a couple of flags to hunt for in here and another program to unpack. So I think that's enough of that one, and I'd like to somehow get my machine to stop going nuts on me here. All right, I'm going to